We're seeing robots like never before. We're seeing 3D printing.
This is now the world's largest 3D printed community.
We're seeing artificial intelligence. There's even a resurgence in nuclear power and the promise of fusion coming in the next decade or two.
We have now entered the era of artificial intelligence. Data centers that power artificial intelligence, they require large amounts of electricity. That's why tech companies are looking into nuclear, because they understand the potential to tap into large amounts of clean electricity.
The only one that we haven't seen to the extent that we expected it was nanotechnology.
The game of science has different rules when you play it in the nanoscale.
I think that's just a delay rather than the fact that it wasn't working.
Nano means 1 billionth. A nanometer is 1 billionth of a meter.
Well, unfortunately, the word has gotten battered and bruised and kicked around since Eric Drexler popularized the term in the 80s.
The center of my work has been understanding what physics tells us about technologies that don't exist today, but that could be developed in the future.
Well, if you go to MIT, back when I was visiting it, they had the biggest collection of science fiction in the world. One of the things they had, a story by Robert Heinlein about building robots that could build other robots, that could build smaller robots and so forth. And by the end of the story, he had gotten that close to the idea of nanotechnology. The basic idea is simple, that you invent a system of mechanism that comprises self-reproducing factories that we can reproduce at the same size levels that cells create machines that do the work inside of cells. Therefore, everything in your factory is actually going to be atomically precise to run much, much faster and do a better job at creating interesting materials and doing chemistry and all of the other things that you want in a machine. I mean, suppose we knew the recipe for a perfect room temperature superconductor, but it was a god-awful complicated arrangement of atoms that was almost impossible to get simply by mixing and heating and cooling and pressing and all the other stuff they do to make materials in modern day chemistry. But if you had the ability to place those atoms one by one, then you can make that superconductor. So there's stuff you can make with nanotechnology, and there's stuff that you can make a lot faster than you could otherwise. And those two together are what give you the key to the future as far as nanotech is concerned. Right now that we can manipulate matter atom by atom or molecule by molecule, but it uses really expensive big machines that use macroscopic means mostly, like the atomic force microscope and that kind of thing. But it's like having a pencil and you're trying to make something out of peas, and all you can do is poke it with the pencil that you can move around. They haven't managed to make something that can pick something up and put it in a particular place and twist it and push it in, or all of the sort of things that you would do when you're actually manipulating something in a manufacturing process.
So to make this animation, we move molecules around one at a time to draw a little picture.
This is a very challenging task because nobody, as far as we know, including ourselves, has ever moved 5,000 atoms.
And that's what's been the holdup, right? Everybody chasing nanotechnology right now is still using macroscopic machines, even though they have found ways of using that pencil and making one piece stick to it and moving it and putting it in another place.
I build with nanomaterials. They are these just impossibly small, fascinating little objects. They're so small that if this controller was a nanoparticle, a human hair would be the size of this entire room.
There's no really cogent criticism that stands up to the idea of nanotechnology, except that, well, why haven't you done it yet? Because we haven't tried.
There's this huge overhang of what we have versus what the world is using, and how that's going to play out, how long it takes the economy and society to catch up.
Clearly, What not to do is what they did with nuclear power. For many years, the head of the NRC was a rabid anti-nuclear activist. And so if you got a department of AI that was going to regulate AI in the United States, and you got a rabid anti-AI activist in charge of it, we would fall way behind everybody else. And right now we can't afford to. If I were put in charge of any segment of U.S. policy, I would adopt as strict as possible of a laissez-faire attitude and let the people who were really interested in it and knew what they were doing, do it. This is what happened with computers. Nobody was going to regulate what kind of computer you can build. As long as that amount of slack is allowed in invention and exploration and development, these technologies are coming. I mean, the field of AI in particular has just taken off like crazy.
Generative AI fundamentally changed how computing is done.
People started realizing, oh, this works. And money, investments, resources, and smart people started pouring into the field in a way that was completely not the case even just 10 years ago from now. Somebody, maybe one of these tech giants who are doing the AI or the other stuff, is going to say, wait a minute, we're missing a bet here, and realize the size of the projects in AI right now are easily of a usable size to find the path to nanotech. I mean, everybody in 2010 thought AI was, this goofy blue sky stuff. It would never work, and then all of a sudden, everybody started pouring money into it.
I think you're very excited about AI and what can happen.
We go back a decade or so, you'll see that it was only 10% of the S&P. Now it's 32%.
All nanotech needs is the same sort of thing to happen. And so the real bottom line is, let's just go and try it and see if it really works as well as we think it does.